वेलकम टू वन अरीना। आज हम बात करने जा रहे हैं मॉड्यूलर की एक प्रोग्रामिंग लैंग्वेज मतलब मोजो एक प्रोग्रामिंग लैंग्वेज है जो मॉड्यूलर की तरफ से आती है। सो मॉड्यूलर ऑर्गेनाइजेशन का नाम है। सो तो पहले हमने देखा था इन्होंने अनाउंसमेंट करी थी कि ये एक पाइथन का सुपरसेट है और ये पाइथन से बहुत बहुत ज़्यादा फास्ट है और हम इसे बेसिकली एआई डेवलपमेंट के लिए यूज़ कर सकते हैं। तो अब ये पब्लिक डाउनलोड के लिए अवेलेबल है, हम इसे अपने सिस्टम्स में यूज़ कर सकते हैं। सो इसे डाउनलोड करते हैं। तो डाउनलोड करने के लिए लॉगिन कर लेते हैं। यहाँ पर थोड़ी सी कहते ना, थोड़ी सी ट्रिक है। दैट इज़ कि ये मैक और लिनक्स के लिए तो नेटिवली अवेलेबल है, बट फॉर विंडोज़ इसके लिए WSL की ज़रूरत पड़ेगी, विंडोज सब सिस्टम फॉर लिनक्स। तो मैंने ऑलरेडी डाउनलोड कर रखा है। आई होप सब बाकी सब भी आराम से डाउनलोड कर पाएंगे। सो मैं सीधे चलता हूँ इंस्टॉलेशन की तरफ। दिस इज़ Ubuntu. Okay. The first step they are saying कि install VS Code, WSL extension, then Mojo extension. तो हम उन सब चीज़ों में नहीं पढ़ रहे। तो वी ऑलरेडी हैव WSL अदर थिंग्स। तो व्हाट वी आर गोइंग टू डू इज हम इसे इंस्टॉल करेंगे, विच इज़ मॉड्यूलर CLI. ओके, जस्ट कॉपी इट एंड पेस्ट इट हियर and wait for it will just check everything and download the modular CLI. ओके, दिस इज डन, दिस इज डन। अब हम मोजो SDK डाउनलोड करेंगे। सो पेस्टिंग इट हियर एंड डाउनलोड। तो थोड़ा सा टाइम लगेगा। तो मॉड्यूलर इज अवेलेबल, हमसे डाउनलोड कर सकते हैं। देयर वर फ्यू क्लेम्स बाय देम कि ये कितनी फास्ट है। तो यू कैन सी हियर दे हैव शोन द ग्राफ, the TensorFlow, PyTorch, and modular engine. So they are saying there's a considerable difference in between TensorFlow, PyTorch, and modular engine. Okay, let's see. Okay, still in the process. There are a lot of things and a lot of documentation which still needs to come out. But okay, this is the start. Yeah, as we can see here, the Python is according to this, Python's run in single thread execution, and they're telling the Mojo will run in parallel processing across multiple cores. So I'm going to show you this, what this means, and this is the comparison, how fast this is in comparison to Python. Okay, they've changed the number. No, 68,000x. Basic neural network diagram. Okay, let's see. Okay, it's done. Okay, so the Mojo is installed. Okay, so I'm just going to write here Mojo. So this is the interpreter. Okay, there's something still left. Okay, we need to do this. Okay, we need to copy all these paths and paste here for bash, and let's try again. Yeah, interpreter is here. So I write print, and यहाँ पर हम जब दो बार इंटर प्रेस करते हैं तब हमारा प्रिंट स्टेटमेंट जो है प्रिंट होता है। तो एज यू कैन सी हेलो वर्ल्ड यहाँ पर प्रिंट हो गया है। सिंपली मैं बाहर आने के लिए कंट्रोल C का इस्तेमाल करता हूँ, एंड Let's go to website again. Okay, and here it says open VS Code. Okay, we'll install that. Let's install VS Code. So we'll use these commands, and I'll just go through with. Yes, yes, and then finally install code. मैं डिस्क्रिप्शन में ये सारी कमांड्स दे दूंगा, so don't worry. Now it's done, so we'll proceed with other things. तो यहाँ पर हम लोगों को बोला गया था कि VS Code इंस्टॉल होना चाहिए, WSL एक्सटेंशन इंस्टॉल होना चाहिए और मोजो का एक्सटेंशन भी होना चाहिए. So let's go to this. Okay, so see what this is. And this is VS Code, same thing. Don't show this message again and continue. Okay, cancel. So what we're going to do is कि यहीं पर हम VS Code खोल लेते हैं. Yeah, so these are extension and we're going to write Mojo. This is from the modular. Let's install this. It's done. And one more thing, we'll create a folder, just Mojo YouTube, and we'll open this VS Code in this folder. हम यहाँ आ गए, and the first thing I want to do is create a hello world Mojo program. Hello.mojo. You can see there's a fire sign here. Okay, I'm going to write print. As we all know, Mojo is a superset of Python, so we'll use direct Python code. Save it. Just saying something. I'll explain it. This is the terminal, and I'll write Mojo hello Mojo. And if we try to run it, it won't run. As Mojo is a superset of Python, this code should run, but we cannot. So how can we run this? हम कैसे run कर सकते हैं इसे? So the way is, as we do it in Rust, C, or Java, we'll create a main. And either def की जगह definition की जगह fn use होगा function. Now I'll save it, and this is going to run. See, and there's one more thing. Mojo. Yeah, we'll try to build it, and now this is built into binary or directly executable file. So now let's close it, and I'll try to execute it directly. Here you can see this is the file, and it is running as this. So this is a compiled version, and here we are running it directly as we do it in Python. So it's not creating any other file, but here with the build command it is. So let's go back to website again. This says get started with hello world. Click on it and go here. This is asking us to export all these paths. So we have already done that, and we have done this also. And I've showed you this part also. Okay, now this is the code which they have given during the playground. Okay, they have given access to few people, and in that they have given this code so that people can try and play with the Mojo programming and compare it with the Python. So what we are going to do is ये पूरी repository है which is open source, publicly available है. So we are going to download this. So let's copy it, just close it, done, and we'll go into this. Then examples. So here are few examples. जैसे कि स्टार्टिंग में मेंडल बॉट एल्गोरिथम्स के बारे में बहुत बात हुई थी, जो सारा पैरामीटर हम लोगों को बताया गया था कि पाइथन से इतनी ज़्यादा फास्ट है, सी प्लस प्लस से इतनी है, और और भी चीज़ें हम लोगों को बताई थी, वो इसी एल्गोरिथम के बेसिस पे थी. सो ये मैट्रिक्स मल्टीप्लिकेशन का कोड है यहाँ पर, which I will explain, and this is in Python, the same thing. And we can run these files. Actually, you can try together and play with this. And let's start. So the first thing I'm going to do is I'm going to run this file. So we'll start with matrix multiplication, and so let's start with matrix multiplication. So I'm just going to run it without any reading. So yeah, this is doing something. Oh, it's installing NumPy. Okay. 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 And there's a file with python.py also. Python 3. And let's run it. Okay. Oh, hit this. Okay. So right now, if we look at gflops, so the basic thing is greater the better. So gigaflops are 0.0004. Okay. And if we go to here, these are 0.003. So with the Python, they have a greater number. Okay, you must be thinking about the other numbers. Again, yeah, here is 6, here it is 49, 40, 96, and 78 and 85. Okay, I'll explain it. So if we'll go here, and this is the code. Here are all the libraries from Mojo and Python. So they are using few Python libraries. So let's scroll down here. This is struct for matrix, define the structure, and the few function. This function is running the Python code. Okay, so run matmul python. So these are the parameters, and it is running Python code. So Python is equals to Python initialized, and then in try except block, and returning the gflops. This is matmul naive algorithm, vectorized algorithm, and this is I think a library of vectorize, and this is parallelized, and similar to this. I'll show you all of this, and this is the main function here. Okay, so here it is saying throughput of a 128 cross 128 matrix multiplication in Python. So what this is doing is this is actually doing a multiplication. Oh, sorry, matrix multiplication. Okay, so for this parameter, and this is the alias for m, which is, and this is 512, which is benchmarking for matmul naive, matmul vectorized, and for matmul vectorized 1, which is a standard library vectorize, and then parallel, which is vectorize plus parallel, and title parallel, title vectorized parallel, which I don't understand right now, and unrolled parallelized. Okay, let's go up. And here what I'm going to do is, as this is, okay, where's the main? Yeah, here's the main. Let's go to website now and we'll see a doc here. And the doc, there is a library as time. So this is a Mojo library, this is Mojo documentation. We'll copy this from here. हम यहाँ से इसे copy करेंगे and import it here. So now we'll go scroll back here. And यहाँ पर हम देख सकते हैं कि Python का कोड है वो रन हो रहा है. So what we are going to do is let. So let me use var first. Var start. Okay, let's just use start. And now. So this will record the time of initialization. And this is the function. And in the end, so this is Mojo में भी कितना same indentation follow होता है. So which is going to be either one space or four space or space which are consistent. Okay, so here it is 4. So we'll write end and now again. And again we'll use var here. And now I'm going to print end minus start. The problem is this time is in nanosecond. So we'll convert this to seconds. Okay, by dividing it with so many zeros. 3, 3, 9 zeros. Okay, we'll save it and I'll show you. It will give us a time. ये हमें time देगा. Okay, now we are getting a warning as we are using start variable and we have declared it using var. Okay, but we have not mutated it anywhere. So ये हमसे कह रहा है कि let का use करो rather than var. So we'll use it. Okay, I'm changing this to let. ये मैंने सिर्फ दिखाने के लिए लिखा था. Save this and we'll scroll down. Everything else is fine. सब कुछ run हो रहा है. And last में आप देख सकते हैं कि यहाँ पर there's a time which is 10 seconds. Okay, but the thing is कि ये एल्गोरिदम ये प्रोग्राम जो है वो 512 पैरामीटर्स के लिए रन हुआ है. I think 1 2 3 4 5 and 6 times. Okay, and 1 for Python plus for one time for Python for 128 parameters. And ये ले रहा है 10 seconds. और अगर मैं सिर्फ पाइथन का प्रोग्राम चलाऊँ विच इज़ गोइंग टू विद दिस, यहाँ पर भी हम जो है टाइम को चेक कर लेते हैं कितना टाइम लग रहा है. विल यूज इम्पोर्टेड प्रोग्राम. तो ये प्रोग्राम जो है मेन से रन हो रहा है इफ मेन से. सो विल यूज time dot time which is going to give us time in seconds. So we'll print save it and now run. And it is taking 1 second. Okay, but that is for 128 parameters. If I'll change it to 512, you'll see a big change. this also. Save it and run it. Now we are running for 512 parameters. Okay, and I wanted to show you this the source. All I have 16 cores and in my CPU, and you can see not every one of them is engaged. Okay, so we are running this for Python for 512. We'll see how much time this is going to take. Whereas we were doing the same मोजो की फाइल में हम लोग ये ऑलरेडी कर रहे थे. Okay, this is not the actual representation because I'm recording also, so don't consider it. बस मैं ये दिखाना चाहता हूँ कि सारे के सारे कोड्स engage होते हैं कि नहीं होते हैं when we use Python code and Mojo code. Okay, right now recording के साथ और बाकी चीज़ों के साथ the codes are working, but एक साथ engage नहीं हो रहे. So it is taking time. You can see that it is taking too much of time now. Okay, this is 118 seconds. Okay, and if we'll go back to Mojo file, and can see that we are already using it for 512 parameters. Okay, this is the M, which is 512. Okay, beside we are using this Mojo file to run the Python code also. So we are running Python code in Mojo interpreter or Mojo compiler. So then also it is taking 10 seconds. Okay, I'll show you. Okay, it is running now, and I want you to keep your eye here. Okay, I'll show you a sudden spike. You can see all the cores are engaged at once. You can see that. Okay, I'll just increase the number for 512 to a significantly large number, which is 2048. You can go higher, but I don't want to take too much of time, so I'll just run it again. Let's just wait. Just wait for a while. Okay, now we are getting output from Mojo code, but not all algorithms in Mojo are acquiring all the cores. So few of them are now. You can see all the cores are engaged, and yeah, this is I think they were talking about. So if you want to use the power of Mojo, then we might need to learn it a bit. So this last two algorithms, I think, use the full all the cores. That was title plus vectorized plus parallelized, title plus unrolled plus vectorized plus parallelized. Okay, I'll try to look through both the part of the codes, and I'll try to explain it later. But this is what I wanted to explain and show you. This is what Mojo is offering, and this looks promising. So what they are saying is they are going to remove the need of installation of C++ libraries and other libraries, and they are significantly faster than TensorFlow and PyTorch. So we don't have to create a bridge between Python and C and hardware. Okay, that's it for this video. Bye bye.